Okay, class, for today's lecture, we're going to keep going over orthographic projections, chapter 3, part 1. Okay, so this is the second video for part 1. Okay, so we've been working on our views in AutoCAD, top view, front view, side view, and completing the views. Okay, so hopefully by now some of you have completed these assignments or close to finishing them up. Okay, so today we're going to focus on creating auxiliary views. So let's go all the way down to back to the lecture, same lecture from last week, except now we're going to cover auxiliary views. Okay, so what's an auxiliary view? Okay, so auxiliary views are used to show the true shape of features that are not parallel to any of the principal planes of projection. In other words, we're not going to do a horizontal or vertical projection like the ones we've been doing in this handout, like this one. So far we've been creating front views, orthographic projection, vertical top view, orthographic projection horizontally, right side view. So now we're going to do one at another angle other than horizontal or vertical. Okay, so let's go back to auxiliary views. Okay, so as you can see here, we have a bent piece of sheet metal. Think of it as a metal ruler, and you bent it into this shape. And now you want to show what the features here look like. So here on this flange, we have a circular hole. On this one over here on the left, we have a slot or elongated hole with a round at the top, as you can see here. Okay, so these you project with respect to, in this case, the axis, right? You project. Same thing with this one. You're going to project with respect to the axis. You're not going to project horizontally or vertically like we've been doing. Okay, so let's take a look at this example. All right, so this view has a front view, right? So let's say this is the building. We're standing here. So we create our front view, right? If you're standing here. And then when you go to the right side of the building, this is the view we get. So this is the right side view. Come back to the front and fly over the top and look straight down. And you get your top view. Notice that from the top view, this circular hole looks elliptical. So this hole is circular, but from this perspective, flying over the top, it looks elliptical. Okay, so once again, it is a cylindrical circular hole, except when you look at it from the top view, it will look elliptical. Same thing from the side view. So if you're standing over here on the side of the building, right side, and you look straight towards the hole, it's also going to look elliptical. The only way you can look at it so it appears circular is if you look down the axis. Okay, so if you were to climb on top and look down the axis of the hole, kind of like looking down a cannon, right? You're not going to do that, but if you were to climb to the cannonball or the cannon and look straight down, look for the cannonball, right? So you would then get an auxiliary view from that. Okay, so let's go on to the next slide so you can get a better picture. Okay, so once again, if you were to look down the hole, right, of this cannon, then it would look circular. Okay, but from the top view, it looks elliptical. From the side view, it also looks elliptical. In order for it to look circular, you have to look straight down the axis. Okay, so we have an axis for this hole. Here's the red hidden lines. Actually, they're not red here, but you know, these are hidden lines representing the circular hole, as you can see. Okay, so it happens that these red hidden lines are perpendicular to this edge. So you just simply rotate about this edge 90 degrees. So remember with Jack, this was Jack's front view. Turn to your right, Jack, and take the steps back, and that would be Jack's right side view. In this case, we're going to tilt and rotate 90 degrees and step back, and this is the view we get. Okay, so let me demonstrate that using your last two problems in the handout. Okay, so if we were to go to the handout, the last two problems are assignments involving an auxiliary view. So you are going to have to complete the front, top, side, and auxiliary view. Okay, so let's take a look at this problem. Okay, so there it is. So if we look at the front view, pretty straightforward, right? We have a vertical groove or rectangular groove. Also this one at an angle. If we look at it from the top, here's what it looks like. So we can clearly see down this cyan rectangular groove going all the way downward, right? But we cannot see the salmon one, right? The salmon one, we can see the opening, but we don't see the exit if we look at it from the top view, right? We don't see the exit. Here's the opening. It's like going down a slide, going to the water park. Okay, so we cannot see it exit at the bottom. As we can see the one on the left, you will see the exit at the bottom at the base. Okay, so let's go back to the front view and take a look at the side view. From the side view, you see part of the opening, right? For the salmon rectangular groove here. We only see part of it from this perspective. We do have to use red hidden lines, right, for our right side view. Okay, let's go back to the front. So when creating an auxiliary view, we want to look down the slide, right? So imagine you're at the water park, you're about to slide down and you look down to see how scary it is at the bottom. Okay, so if we were to look straight down, just like looking down a microscope, you're going to angle your head slightly so you can look straight down to see what cells, are at the are underneath the slide and so on. Okay, so here is our line, and just imagine drawing a perpendicular line and rotating about that perpendicular line, and we're going to rotate, and that's what we get. So now we're looking down the slide. It looks a little scary, right? It's dark, shadows, you don't know what's at the bottom. Okay, so this would be our auxiliary view, and the whole purpose of this is to be able to dimension this rectangular slot. Okay, in this case, the salmon colored slot. Okay, you get a good view of it, and you can dimension it, but we're not going to do dimensions in this chapter nor this handout. Okay, so that's the whole purpose of this view, for clarity and to dimension. Okay, all right, so let's take a look at the next problem. This one's a little bit tougher. The author, she chose to make this one a little bit tougher on you guys. Okay, so we still have the front view, top view, side view. Very similar to the lecture example. Not exactly the same, but very similar. As you can see, you have your circular hole and you have a slot here on this side, right? You can see the slot, a rectangular groove. You don't have it on this side, but you do have it on the handout. So this one has the two slots or rectangular grooves along this wall and the opposite wall. And something to note is that the slot is not in line with the axis of the hole. Typically something like this would be in line with each other, but to make it more challenging, the author decided to give a different angle for the slot versus the hole. As you can see here in the front view, we have the slot and the axis of the hole at different angles. They're not at the same angle, so it forces us to create two auxiliary views. One auxiliary view for the slots and the other auxiliary view looking down the axis of the hole. Okay, and once again, see how the circular holes here look elliptical from this perspective, same from the top. In order to get a nice clean circular view, you have to look down the axis of the hole. All right, so let's take a look at that in 3D. Go to the next model. Okay, so you're going to have your front view and your top view. Notice how the hole looks elliptical back to the front, and then let's go to this right side view. Once again, the hole is actually elliptical from this perspective. In order to see the circular hole appear circular, you have to look down the axis, as so, right? But we have to project from our reference view, in this case the front view. Okay, so for the first one, we're going to look down the slot. So our first auxiliary view, let's go back to the PDF file. I'm going to go all the way to the end to the solutions. I'm going to cheat, go all the way to the bottom. Okay, so here's what it looks like. Okay, so we have our auxiliary view looking down these rectangular grooves or the slots here, right? It's like looking down the slide and seeing the exit. Once again, the green center line for the axis of the circular hole is not at the same angle as the slot. Okay, so the first auxiliary view is looking down the slots. The second auxiliary view is looking directly down the axis of the hole. Notice how we don't see the bottom of the slots anymore. They're there, but we just can't see them from this perspective. Okay, so let's first look at the one on the left here, this auxiliary view. Okay, so we're going to rotate with respect to this edge. I believe this edge is perpendicular to this line, so we're going to rotate about this axis line, this edge, rotate, and we're going to look down the rectangular slot so we can see it exit. Notice how we don't see the complete exit of the circular hole, and that's because they're not at the same angle. The axis of the hole doesn't have the same angle as the rectangular grooves or slots. Okay, so this is what our auxiliary view looks like for our first auxiliary view, right in the handout. There it is. Now let's look down the hole. So we're going to get this view. It looks directly down the axis of the hole. Okay, so let's go back to the 3D model. Okay, so once again, let's go back to the front view. Now instead of the slot, let's say we look straight down the axis of the yellow circular hole, and this is what it looks like. So now we're looking right down the circular hole. We can see the exit, it's circular. Now the slots, we can no longer see the exit. Notice if we tilt it slightly, now we can see them. But for this auxiliary view, we're going to look down the axis of the hole. Okay, so this is an introduction to auxiliary views. Okay, let's go back to the lecture. And some of the commands we're going to cover when we go over these two problems in separate videos. I'm going to show you how to use align and lengthen and user coordinate system. We're going to use a user coordinate system to help us create those auxiliary views. We're going to create an axis system at an angle with respect to the views. So we would put an axis system here at this orientation to help us create our detail lines or features, our object lines, hidden lines, center lines. Okay, and once again, we'll be creating our user coordinate system. And once you're done and you submit your work, again, there's no due date. I'll grade your assignment. If you're missing anything, I'll point it out, give you your points. If you don't get the full credit, you can resubmit a second time, but only a second time to improve on your score. All right, so once again, I will be providing separate videos for the last two problems on this handout, problem 11-13, and the previous one, problem 11-1. Okay, see you in the next video.